Alright, so we've talked about adding and subtracting fractions, and we've talked about multiplying and dividing them. Now we're going to talk about, how do we change that into maybe a decimal so it maybe looks more friendly to you. Some people might not care for fractions. Some of you might think, I never want to look at a fraction in my entire life. So how do we change it to a decimal? So we have a couple steps here. We're going to set up the division problem. So remember we talked about in adding and subtracting that fractions really just mean division. So a over b is a divided by b. 3 over 4, like our first example here, is 3 divided by 4. And then we divide it. We're going to kind of do some long division type stuff to first, so you kind of get the idea of where it comes from. And then we will go from there when I get about how to kind of simplify this and shorten it up in a little bit. When you're doing the division, if you start to get the same number each time, you're repeating a pattern, that means it's going to be a repeating decimal and you can stop. And we'll talk about that too. So let's look at this first one. 3 divided by 4. See, 3 divided by 4, so I set up the long division. We're going to go back to, that looks more like a square root, which is not what we want. Back to my kind of long division days. So 3 divided by 4. So the number that's being divided goes on the inside, and the number that I'm dividing by goes on the outside. Make a little decimal place because I know that that's there. And then I look and I say, okay, does 4 go into 3? No, it doesn't. So I need to add a 0. 3.0 is the same as 3, so I can do that. Then I look, does 4 go into 30? Well, I know 4 times 7 is 28, so 28 can go into 30. So I make my 7 up here, I bring my decimal point up right above it, and then I do 7 times 4. 7 times 4 is 28. I do the subtraction, I have 2, and I bring down another 0. Does 4 go into 20? Well, I know 4 times 5 is 20. So I do 5 up there, 4 times 5 is 20, and I get 0. Now I'm done. 4 doesn't go into 0, so I'm done. So 3/4 as a decimal is 0.75. Not too bad to start. Alright, so I look at 5/9. So 5 divided by 9. So I set up my division. So 5 is being divided by 9. Look at, does 9 go into 5? Well, no, because 9 is bigger. So I add my 0 and I bring my decimal place up. So 9 goes into 50. What's the biggest amount of times I can do that? Well, 9 times 5 is 45. It's the closest I can get. So 50 minus 45 is 5. Bring down the 0, and I get 50. Well, I'm at the same spot I started with, so it goes in 5 times. 45. 50 minus 45 is 5. If I bring down another 0, I'm going to end up with, this is where I start to see that pattern. So that means that it's going to keep repeating. It's just going to be a 5 every time, because I'm going to end up with 50 and 45 and all that stuff. So it's going to keep repeating. So instead of keeping going, I notice that pattern starts to happen. So my decimal is going to be 0.5 repeating. It's never going to stop. There's no reason to keep going with the division because it's just going to keep going. So let's look at a couple more examples. So 3 divided by 5. So I set up that division. So 3 is being divided by 5. I have my decimal point. 5 obviously can't go into 3 at all. So I need to add a 0 and treat it like a 30. So how many times does 5 go into 30? What's the closest I can get? Well, 5 times 6 is 30. So 6, so 5 times 6 is 30. 0, which means I'm done. I can't go any further. So 3/5 is 0.6 as a decimal. Alright, next one. If I look at 1 divided by 8. Now that's where you got to be careful because I did that backwards. So I want 1 goes in the inside divided by 8 outside. So I look and I say, does 1 go into 8? Or does 8 go into 1? Well, no, it's obviously too big, so I add my 0. So how many times does 8 go into 10? Well, it goes in 1 time. 1 times 8 is 8. 10 minus 8 is 2. So I add that other 0 and bring it down. And say, how many times does 8 go into 20? What's the closest I can get? Well, 8 times 2 is 16. So the closest that I can get is 16. So 2, 16. 20 minus 16 is 4. Bring down the other 0. And then again, we follow the same steps. What's the closest I can get to 40 by multiplying something by 8? Well, 8 times 5 is 40. So 8 times 5 is 40. 0, so I can stop. So 1/8 is the same as 0.125. So last two examples here. So 2/3. 2 divided by 3. So when I set this up, I have 2 divided by 3. Say, does 3 go into 2 evenly? Well, no, because it's bigger. That seems to be a bit of a problem as we start this out. So how many times can I multiply 3 by to get it as close to 20 as possible? Well, 3 times 6 is 18. So you get to 18. 20 minus 18 is 2. Bring down that 0. Again, the closest I can get to 20 is 6. And minus 2. Bring that 0. Hopefully you've started to see the pattern. It's always going to be 18. And then I'm going to subtract it. I'm going to get 2. I'm going to bring that 0 and make it 20. That pattern is going to keep going. You could divide this until class ran out of time. You would still get 20 every time, 18, and 2, and that. So my answer is going to be 0.6 repeating. Alright, last one. 7 divided by 8. So 7 divided by 8. Only by now you're kind of seeing the pattern here. It's never going to go in the first time, so I need to add that decimal place, I need to add that 0. So look at what's the closest I can multiply 8 by to get to 70. Well, in this case, 8 times 8 is 64. So I can do that. So 8 times 8 is 64. 70 minus 64 is 6. 8 doesn't go into 6. So like I've been doing this whole time, I'm going to bring down a 0. What can I multiply 8 by to get as close to 60 as possible? Well, 8 times 7 is 56. So I'm here. 60 minus 56 is 40. What can I multiply 8 by to get as close to 40 as possible? Well, 8 times 5 is 40. Using my subtraction, I end up 0, which is what I want. That means I'm done. I don't have to keep going. So 7/8 is the same as 0.875.